What's up guys, in this video we are going to learn about collection interface and see what are the various functionalities provided by the collection framework, right? So it is probably one of the most important topics in Java, and I recommend you to really take this section very seriously. So let's start with what is exactly a collection framework. The Java collection framework provides a set of interfaces and classes to implement the various data structures as well as algorithms. In the past, we have seen about the arrays, but those were fixed size arrays. Let's say if you want to have a dynamic array data structure, so collection provides you that, right? Provide that functionality. So by using the collection framework, we can create dynamically resizing arrays, which is called as an array list, right? You'll see that in when we implement the array list using collection framework. Also, the collection interface also provides the means to store and manipulate the group of objects. We will see those methods in the next few slides. So basically, let's go to the next slide. So it talks about what is exactly a collection framework. So a collection framework actually provides a framework slash, an implementation for various data structures and algorithms. So the interface for the collection is this collection with a diamond operator as E. E is nothing but the elements or objects inside the collection. A collection represents a group of objects known as elements, right? The collection provide the architecture or framework to store and manipulate the group of objects. So let's say, for example, you have a dynamic array, which we call it as an array list, and that array list actually stores the names of the person, right? So it's basically a dynamic array of a string, right? So a person name is basically a string, so dynamic array of string. And if you want to remove, add, or manipulate any kind of data, so collection provides various methods to do that, as well as it provides the many interfaces such as set, tq, list, queue, map, sorted set. We are going to see about all this in the next few slides. So the URL for the documentation is this. You can go to this URL and check, what exactly is collection. They have, talked about the various collection. So let's go back to the next slide. So this is basically how the collection interface really looks like. So if you notice here, right, if you notice here, you have a collection at the top. So this is collection interface is root of collection framework. So a collection is actually an interface inside the Java. And if you notice here, this list, set, and queue, these are also interfaces. And these interfaces extends the collection interface, right? In interface, we have seen that an interface can extend an interface. So in this list, set, and queue is actually extending this collection interface, as well as if you notice here, the sorted set is actually extending the set interface, as well as the DQ interface is actually extending the queue interface. So this is how the collection interface really looks like. There is also a separate called as a map interface, which you will see, right? So but the collection interface looks something like this. Also, what are the sub interfaces in collection? So there are various sub interfaces. The first one is a list interface. A list interface is nothing but it provides a data structure like an array list, vectors, linked list, and stack. These data structures are nothing but the ordered collection of similar objects, right? So if you want to have a person name, so that's basically a string. So you can have, you know, this a collection of string, right? So inside string you cannot have integer. That's not possible in the list interface. So if you define the type of data it holds, so that type should remain constant throughout the list. The other is a set interface. So unlike list interface, the set interface cannot have duplicate elements. So this is same goes with the mathematical model. So in mathematics, a set will not have a duplicate elements as this. So this concept is same in Java, right? So a set interface has classes which it cannot have a duplicate objects or duplicate elements inside it. There is one more. The other type is a queue interface. It provides functionality for implementing the queues data structure. So queue data structure, it's basically like, the first, it works in first out manner. So whatever element you push first, and if you want to, peek the data, you will get the first object itself. So first in first out manner, or FIFO manner, right? So while implementing, you will understand it better. The other one is a map interface. So a map interface actually provides the functionality for implementing the map data structure. A map data structure is nothing but a key value pair data structure. In short, it is called as a dictionary, right? So it has keys, and then it has a value. And if you want to get the value of a key, what you do is you do a get operation on whatever key is, and you will get the value. So in the next slide, we have the various methods in collection. So these are the methods which are defined in collection interface. The first one is add, right? So add method actually inserts the specified element to the collection. So this add method is actually accepting a parameter of an object, right? So let's say if you have an array list of string, so inside this add method, you are passing the string value and it will be added into the array list. The second method is size. It actually returns the size of the collection. Then we have the remove method. It actually removes the specified elements from the collection. So this remove method actually accepts an argument of position, right? So if you want to remove an item at position 3, you can call remove 3, right? With a argument, with a parameter of integer 3. There is also one more interface which is called as an iterator. This is actually an interface to access elements, or rather to iterate through each of the elements. So in the past we have seen, if you want to iterate through an array, we use for loop. So instead of for loop, you can use iterator, right? Also, the next method is add all. Let's say that you define two collections, or for example, let's say you define two array lists. The first array list holds the names, right? And the second array list holds, let's say the contact. So if you want to add a contacts into a names array list, you do add all operation. So don't worry about this. You just need to understand like what are these methods, and I'm going to show you via an implementation what these methods actually does. So add all actually adds one collection into the other collection, right? Then we have a remove all. This actually clears, or rather remove all the elements of the specified collection from the collection. It is same as clear. It actually removes all the elements of the collection. This is, remove all or clear will work the same way, right? So then we have the first interface, which is called as a list interface. So a list interface is an ordered collection that allows us to store and access elements sequentially, right? So we have seen the raw arrays in the past, right? One dimensional as well as two dimensional. But this interface actually holds the wrapper type of data. So here I have given one example as list of string names, right? So here you can have integer with the wrapper class integer, but you cannot have the primitive int, right? That's not supported here. So inside this open and close, this is called as a diamond, and this is a generics, right? We have seen what is a generic. So the classes that implements list are array list, vector, linked list, and stack. So what does this mean? So as list is an interface, these four below are classes that implements this list interface. And list interface, we have seen from the second slide, actually implements or extends the collection interface. So list interface extend collection interface, and these four classes implements the list interface, right? So we have an array list, then we have a linked list, we have stack, and then we have a vector. So the widely used is an array list if you want to have a good performance, right? Array list and vector are very much similar, but the vector is, a thread safety. They have every operation inside vector is synchronized. That means there is a lock for an operation. If you want to have a better performance, I suggest you to use array list over vectors. So a linked list is basically a data structure which has a nodes, right? It has a pointer to the next element, as well as it has an element and then it has a pointer to the next element. So each data structure like array list and linked list has pros and cons, which you will see in the later chapter. And then we have a stack. The stack work in last in first out, so it actually implements the list interface, right? So we are going to see that as well. So this is all about the list interface. The second interface is a set interface, and we have talked about that set is a collection that cannot contain duplicates, right? So let's say that you have two elements which are same, right? The value is same, so only one will be considered, the other will be discarded. So it cannot have a duplicate elements. This becomes very handy when you want to have a, a requirement in such a way that you don't want the name of the person to be duplicated, or rather the contact number not to be duplicated from the list of record. So you can use the set interface, right? So the classes that implement set are hasset, linked hasset, enum set, and tree set. So if you see here the hierarchy, right? So the set is an interface here at the top, right? This is an interface at the top, and this enum set, hasset, linked hasset, and tree set are basically classes that implements the set interface. Also, at the right hand side, you have a sorted set. This is basically an interface, one more interface that extends set interface, right? And then we have a navigable set interface that extends the set interface, right? So these two are interfaces and these three are classes. So set interface is extended by sorted set and navigable set, and the example here is this. So you can have a set of string names is equals to new hash set. So basically this is going to create an hash set, right? So as hash set is implementing the set interface, so this will have all the functionality for the hash set, right? And then we have a queue interface. The queue interface provides functionality for implementing the queue data structure. We have talked about the queue data structure. The queue data structure elements are accessed in, first out manner. And the classes that implements the queue interface are a ready queue. You have again a linked list. Priority queue. We have seen linked list in list interface, right? So a linked list also, implements the queue interface, which we are going to see from the source code as well. So if you see here at the bottom, at the left hand side, these three are classes at the bottom: a ready queue, linked list, priority queue that actually implements the queue interface here. At the left hand side, or at the right hand side, sorry, we have three interfaces at the bottom that extends this queue interface, right? And then we have a map interface. Map interface provides functionality for a map data structure. We have seen map data structure is nothing but a dictionary. So elements of map are stored in key value pairs. Keys are unique values mapped to the values, right? So keys should be unique. You cannot have two keys with same name, right? You cannot have a duplicate key inside a map data structure. The classes that implements the map is hash map, right? Then enum map, linked hash map, weak hash map, free map. So we are going to see about all this one by one in the later tutorial. And if you see here at the bottom, we have 5 classes that implements the map interface, and the map interface extends the collection interface. So if you see in all of this interface, the collection is the root of all, or rather the mother of all, right? Collection interface sits at the top, and then we have the various interfaces, and then we have the classes or the data structure classes that implements these interfaces. So this is all about this collection framework. From the next tutorial, we are going to start off with a list interface, and the first one is the array list, right? So we are going to learn about the array list and how do you define and declare the array list. So catch you up in the next tutorial. Till then, goodbye and see you.